Good day, sir. Here are my 5 sample problem for the lesson heat energy. So first problem. 542 grams of gold raises its temperature from 40 degrees Celsius to 80 degrees Celsius with a given specific heat of 1.30 times 10 to the power of 2 joules per kilogram degree Celsius. How much heat energy was absorbed by the gold? So first step, let us look for its given first. Givens are the mass, which is 542 grams, or which is equivalent to 5.42 times 10 to the power of negative 1 kilograms. Its specific heat, 1.30 times 10 to the power of 2 joules per kilogram degree Celsius. And its initial temperature, which is 40 degrees Celsius, and the final temperature, 80 degrees Celsius. The absorbed heat is what the problem asks for. So let us look for the heat absorbed by the gold. Solution. Q equals mc delta T. So substitute for the given. 5.42 times 10 to the power of negative 1 kilograms times 1.30 times 10 to the power of 2 joules per kilogram degree Celsius times 80.0 degrees Celsius minus 40 degrees Celsius. Copy. 5.42 times 10, 1.30 times 80 minus 40 is 40 degrees Celsius. So if we will calculate that, it would result to 2,818.4 joules or 2.82 times 10 to the power of 3 joules. And this is what we look for, which is the heat absorbed by the gold. Second sample problem. From 40 degrees Celsius to 25 degrees Celsius, the 50 grams of iron is cold. Calculate the heat loss when its specific heat is 4.60 times 10 to the power of 2 joules per kilogram degree Celsius. So next, let's look for the given. Mass is equivalent to 5.00 times 10 to the power of negative 2 kilograms. Specific heat, 4.60 times 10 to the power of 2 joules per kilogram degree Celsius. Initial temperature, 40 degrees Celsius. And the final temperature is the 25 degrees Celsius. So we were looking for the heat loss of the iron. So solution. The same formula, Q equals mc delta T. Substitute the given 5.00 times 10 to the power of negative 2 kilograms times 4.60 times 10 to the power of 2 joules per kilogram degree Celsius times 25 degrees Celsius minus 40 degrees Celsius. Copy. 5.00 times 10 to the power of negative 2 kilograms times 4.60 times 10 to the power of 2 joules per kilogram degree Celsius. 25 minus 40 degrees Celsius is equivalent to 15 degrees Celsius. So to compute, it is equivalent to negative 345 joules, which is the heat loss of the iron, which is cold. Cancel the same unit, which is kilogram, and degree Celsius. That's why we will use the unit joules. So negative 345 joules is the heat loss by the iron. Next problem, the third one. The mass of water was heated with 35,550 joules, raising its temperature from 20 degrees Celsius to 27.5 degrees Celsius. Calculate the mass of the water in grams. So first, let us look for its given. Given the absorbed heat, 35,550 joules. Its specific heat, 4,190 joules per kilogram degree Celsius, or 4.19 times 10 to the power of 3 joules per kilogram degree Celsius. Delta T, or its final temperature, which is 27.5 degrees Celsius, minus its initial temperature, which is 20.0 degrees Celsius, is equivalent to 7.5 degrees Celsius. And what we've asked for is the mass of the water in grams. So, mass is the missing here. Solution. Let us still follow the formula, which is Q equals mc delta T. The Q is the 35,550 joules equals the mass, which is the missing. So let's put X in here. The specific heat, 4.19 times 10 to the power of 3 joules per kilogram degree Celsius, and delta T, 27.5 degrees Celsius minus 20 degrees Celsius. So copy 35,550 joules times the mass, which is X, times 4.19 times 10 to the power of 3 joules per kilogram degree Celsius. 27.5 degrees Celsius minus 20 degrees Celsius is 7.5 degrees Celsius. Still copy 35,550 joules equals 4.19 times 10 to the power of 3 joules per kilogram degree Celsius times 7.5 degrees Celsius is equal to 31,425 joules per kilogram. Cancel the same unit, degree Celsius. That's why joules per kilogram times X, which is the mass. Copy 35,550 joules equals 31,425 joules per kilogram times X. To cancel, let us have over 31,425 joules per kilogram, and also here let us put 31,425 joules per kilogram. So cancel 35,550 joules divided by 31,425 joules per kilogram is equivalent to 1.13. Cancel both units, which is the joules. So 1.13 kilograms is equal to X. So as in the problem is the mass of the water in grams. So since 1.13 is in kilograms unit, let us convert it to grams. So 1.13 kilograms is equivalent to 1,130 grams. So 1,130 grams is the mass of the water in grams. The fourth sample problem for heat energy. 500 joules of heat is absorbed by 250 grams of granite. If it started at room temperature of 20 degrees Celsius, what was its final temperature? So, still let us look for the given. Given heat absorbed 500 joules, the mass 250 grams or 2.50 times 10 to the power of -1 kilograms. Its specific heat 800 joules per kilogram degree Celsius. Initial temperature 20 degrees Celsius, and the unknown or the missing in the problem is the final temperature. So let us find for its final temperature. Solution. Q equals mc delta T. So to look for the final temperature, let us have delta T equals Q over mc. Substitute Q equals 500 joules over M, 2.50 times 10 to the power of negative 1 kilograms times C, 800 joules per kilogram degree Celsius equals 2.50 times 10 to the power of negative 1 times 800 is 200 joules. So 500 joules divided by 200 joules degree Celsius is its delta T. Delta T equals 2.5 degrees Celsius. Cancel both units or cancel the same units, which is the joules. So we have delta T equals 2.5 degrees Celsius. To find its final temperature, which is the missing in the problem, let us have final temperature equals initial temperature plus delta T equals its initial temperature 20 degrees Celsius plus its delta T 2.5 degrees Celsius is equivalent to 20 degrees Celsius plus 2.5 degrees Celsius is equivalent to 22.5 degrees Celsius. So 22.5 degrees Celsius is its final temperature. The last sample problem, which is the fifth one. An ethyl alcohol in a bottle, which is 500 grams, raises its temperature from 30 degrees Celsius to 60 degrees Celsius with the given specific heat, which is 2.43 times 10 to the power of 3 joules per kilogram degree Celsius. How much heat energy did the ethyl alcohol absorb? So, what is asked in the problem is the heat energy that the ethyl alcohol absorbed. So, let us look for its given. Given mass equals 5.00 times 10 to the power of negative 1 kilograms. Its initial temperature 30 degrees Celsius, the final temperature 60 degrees Celsius, and its specific heat 2.43 times 10 to the power of 3 joules per kilogram degree Celsius. And the missing one is the heat absorbed by the ethyl alcohol. So to find for that, let us have the solution here. Q equals MC delta T. Substitute the given. M is equals to 5.00 times 10 to the power of negative 1 kilograms. C, 2.43 times 10 to the power of 3 joules per kilogram degree Celsius. And delta T, 60 degrees Celsius minus 30 degrees Celsius. Copy 5.00 times 10 to the power of negative 1 kilograms times 2.43 times 10 to the power of 3 joules per kilogram degree Celsius. 60 minus 30 degrees Celsius is equals to 30 degrees Celsius. So to calculate that, it would equivalent to 36,450 joules. So the heat absorbed of the ethyl alcohol is 36,450 joules.